Okay, fine. So let me start. So first, what we do is like you have a board, and I have basically created a slots. So I was actually asked the children in the last class to get a carton box board so that I can help them to make the slots and all. But yeah, those children they haven't joined yet. Let them join. So we'll not wait for them. Okay, so I'll just show you how I do it. First thing is I've cut out these smaller pieces. Okay, so I put these pieces inside this on all four sides. Okay, one, two, three, and four. Okay, so on all four sides, and they just then yeah generally if it is loose, what I do is on the other side I put rubber band. Okay, so I'll just show you. I'll put the rubber band and then show you. Okay. Okay, see, I just put some rubber band so that it just holds this together. Okay. So now I start placing the magnet. Placing the magnet is a very tricky thing in this. Okay. So you place two magnets here, so you can see that there are two ring magnets. Okay. So now I require two more ring magnets, but now I cannot directly place it. Okay. What I do is I check if the magnets are repelling for this. Repelling the first two magnets. Okay, while they are repelling, I just place them here. Okay, so I kept it here. So I do the same thing for the other side. Okay, with the second magnet which I placed, first magnet also, like I see if it is repelling. See, it's repelling. I'm not able to, like, it's not attaching. It's not attracting. Okay, so I just place them here. So three is done, and I have to place one more. Okay, okay, so I'm holding it like this. And see, now it is sticking. So while it is sticking, like I cannot have it. Okay, I cannot place it. I'll turn the face and see that like now it is repelling and I just place it here. So you have four magnets, four pairs of magnets placed, and all the magnets are repelling. Okay, that's very important. Okay, then I put this another board on top of it. This is basically help to hold the magnet in its place. Okay, what we are doing is today we are trying to do magnetic levitation. Basically, we'll be making a pen to levitate with the magnetic force. Okay, but this the same principle is also used by the maglev train, magnetic levitation train. So I put the other boards. So now what this other board does it? You just require two boards, one at the bottom and one at the top. So this will hold the magnets in its place. Okay, but many times what the mistake the children do is that they don't ensure that all the magnets are repelling each other. They just place it as it is, and later on they find it difficult that the pen is not levitating or the pencil is not levitating. Okay, this I keep it aside. Just a minute, I'm making some alignment so that you can see both me as well as. Yep, yes, good. Okay, on the back side, you see my store, like I have all this material stored here. Okay, so this is done. And now with this, I'm putting one more piece on this, which I call it as the stopper. Okay. Okay, I put that, and even for that, because even that is loose. So what I do is I put a rubber band so that it stays there. Okay, now it stays there. Okay, so now with the preparing, I need to prepare this pen so that I can make this pen levitate. Okay. Hi, Siddhant. Hi, Dhriti. Okay. What I'll do is, children, just for the benefit of Siddhartha and Dhriti, I'll quickly remove this magnets and again place it back, because placing the magnet is the important part. So later on, everything else is like easy. Okay, children, like I was just what I've done is taken this is almost like a carton box board in which I've cut out these pieces. Okay, so then I place these some four pieces on all four sides and put rubber band on the back side. And now the important part is to place the magnets. Okay, this is the important part. That's the reason I'm repeating. Okay, so I place the magnet here. Two magnets I have placed, and the second magnet now I want to place one more pair of magnets here, but I check if it ripples here. See, now it is sticking. I cannot, while it is sticking, I cannot place it here. It should be rippling. Okay, so I turn the face, and now you see that it ripples. While it ripples, I place the magnet here. So similarly, I do for the other two places. Here, so it is rippling. So I place it here. Okay, and again I'll check it with this source. It's sticking. While it is sticking, if it is sticking, it will not work. Okay, I'll tell you why. I'll remove it, turn the face. Okay, now it's rippling. So I'll place it here. Okay, after all this placement, the simple thing I do is I just put this board on top of this. So this board helps in holding the magnets in its place so that the magnet doesn't move. Okay, so now it's there. So what I do is I again like put some rubber band so that the board also stays there in its place. Okay, and now I'm like inserting this I call it as a stopper. Okay, which will basically stop the pen from moving forward. So okay, the stopper is also in its place. Okay, so now I need to prepare the pen. Okay, so for preparing the pen, I have the smaller rings. Okay, in place of the smaller rings, you can also use rubber band. Okay, you can also use rubber band in place of the smaller rings. Okay, so I'm inserting one ring through this almost till the end. And here I need to attach one magnet, and I need to ensure that that magnet is repelling with the magnets on the backside. Now, in this activity, everything should be repelling, because if it is attracting, what will happen? It will not float. It will just come and sit on the other magnets. Okay, we need to ensure that everything is repelling. Okay, so this is repelling. Okay, I can see that it's repelling. While it is repelling, I'm just taking it and inserting it into the pen, and I am like putting another ring on top of this. See here, okay, yeah. Okay, now I put one more ring. I think I have less rings, but I have a rubber band. I can also show you how I use the rubber band. Okay. So now I insert one more magnet, and since I don't have another ring, I'm using the rubber band. I'm just doubling up the rubber band and pushing it in. Okay. So now on this we have to see nothing is happening. So magnetic levitation is a very tricky activity, children, that like you do something and it doesn't work. So now I need to adjust the length of the magnet. Move the magnets a little forward backward to make it to levitate. Okay. So the idea is that the magnet on the pen should come on top of the magnets on the board. Okay. It should come like almost on top of it. Oh, see, this I put it wrong. I'm sorry, this I did not check. You see this, children? This I made a mistake. It should not attract. Okay, it should ripple. So what I do is again I remove the rubber band. I take it out and turn the face and put it. So now it should ripple. Okay, so yeah, it's actually it is giving some effect, but it is still not staying. Okay, just coming off. Okay, so I'll push this magnet little bit in the front. So we have to make this adjustment. Okay, this adjustment will happen when you do it. Okay, it's still coming back. So what I'll do is this magnet at the back, I'll push it little front. Okay, let us see. Okay, so now this levitates, and you can see that there's a like clear gap between the board, magnets on the bottom and the magnets on the top. See this? There's a clear gap. So now this has started levitating. Okay, so levitating like with the force of the magnet. So what I do is sometimes I also spin the pen like this, and it keeps spinning for a longer time actually. So other thing I do with CF, like I just like gave a small twist, and it's spinning for so long. Okay, many times what I do is I attach a fan on the backside of this, and I just keep it. So whenever there is an like a breeze or some flow of air, then it automatically starts moving. Okay, so yeah, I keep playing with it. I don't know. I don't see a fan right now in front of me. Okay. Okay, so this is all about like making a pen levitate, and this is exactly the same fundamental or principle which a magnetic levitation train uses. Okay, so magnetic levitation train also has, but there in case of magnetic levitation train, they will not use a permanent magnet as we have used here. They use a magnet called as the electromagnet. You guys would know electromagnet, right? You just
Yes.
take an iron piece and you put copper wire, it becomes a magnet, right? And you power it up and it becomes a magnet. But in that, the best part of electromagnet is that if you change the flow of electric current, then you can change the phase of the magnet. That is, you can change north and pole. If the current flows from one direction, it might be north. If we make the current to flow from the other direction, it will become south. So instantly we can change the phase of the magnet north and south very quickly. Okay, so that's why they use electromagnet in the maglev train. So that suppose I have the train here, and suppose I just let's imagine that this has a south pole. So what should be this pole for the train to pull it in the front? This is south pole. What should be this pole for pulling the train to the front side?
North.
Yeah, so exactly right. So this should be north, but okay, sorry. Uh, so this is south, okay, and this is north. So if this is north and south, it will attract. But if I keep it north, what happens? It will just come and get stuck here. So while the train comes, what should happen? As soon as it is coming closer, I just change the phase of this. I change it to south. So then what happens? This will get rippled. It will just move further. Okay, like that, you need to instantly change the phase of the electromagnet of the magnet in a magnetic levitation train. So that's a whole reason. What happens is that we use electromagnets because instantly using some computer program, you will be able to change the phase to north, shift the phase between north and south. So right now there is south and there is north. This should be north until the train comes closer. Once it comes closer, if you leave it north, what will happen? The train will just get stuck to this. Okay, we don't do that. As soon as while it comes closer, we just change the phase, then it gets rippled and it just moves forward. And there's one more magnet which is north on the other side, which is trying to attract this. Okay, like this, you just keep changing north and south, north and south. the robot move forward. For making the train move forward, and this can happen only with the help of electromagnets. Okay, that will lead basically for the next class. The next class, what we are going to do is we are going to do build electromagnet. Okay, so and also learn the electromagnetic principles. So I might have a measuring instrument where I can basically measure the amount of current or the direct, no, not the amount of current, and at least show the direction of current and show like when direction of current changes, how it changes to north and south. Okay, so there's one more activity I wanted to do, but it's a very simple thing. But let's do it. Uh, okay, so okay. Okay, any questions in this? Please ask questions. Like instead of doing other one more activity and like finish off the time. So I would like to hear questions from you guys. Yes, Siddhant. Yeah.
So when the train pass through the magnet on the magnet, how it's changed the position automatically?
No, in this case, it doesn't change automatically. But when the train, what happens, as it says, the electromagnet has that capacity. Okay, electromagnet means what? It is the current. You give electric current, okay, to create a magnet. Okay, so that's what this I'm going to show it to you in the next class practically. Okay, but if you change the flow of current, suppose the current is flowing from this direction. Okay, like it will be south, and make the current flow from this direction. This side would be north, and that side becomes south. Okay, changing the flow direction of flow current, you change you change the phase of the magnet. So this I'm going to show it to you like in the next class practically by having some measuring instrument which will be able to measure the the flow of current. Okay, the direction of flow of current. Okay, you can see that when we change it, like then it becomes north and south. I'll also prove to you that like the phase is changing north and south. Okay, so this I'll do it in the next class because that will take a lot of time to do. So any other questions you guys have? No more questions, is it? Okay, if there is no more questions, I think like we have about 5 minutes time, and I would love to do like another activity. See, what I do is before coming like starting the session, I generally like keep some material ready for cut and ready so that I don't spend time cutting the material during the session. Okay, so this is again related to car. I'm going to do one like magnetic car. Magnetic car, like like without touching the car itself, will be able to push the car. Okay, so I'm just putting a double side. This is just a double side tape. Okay, I'm putting a double side tape, stuck it here, and I'm sticking another double side tape on the other side. Okay, I generally keep all these things prepared. Okay, so in the PrayogPeti box, these things are already there: double side tape and like some magnets and everything, straws and everything. So you can basically use them for making your experiments. So I've cut out these wheels as well. Okay, we need 4 wheels. Okay, I'm taking 4 wheels. Okay, okay, and I'm attaching a what is this? An axle to it. So axle is little loose, but yeah, I'll just keep it for now. Okay, on the other side also I've attached. Oh, before attaching the axle, I should put one more thing. I put this. Okay. Okay, so now I have to attach just the one more wheel. I need to prepare one more wheel. So the carton box material, children, that's the best thing. Okay, so whenever you have get carton boxes, don't throw them, because they can help you a lot in terms of building such building activities. Okay, so cars, like whatnot. Okay, so I fixed the wheels now. So the car is ready. So now I need to do something that can make it to move. Okay, again, what I'm doing, I'm going to attach a magnet here, two magnets. Okay, the slot is little small. What I'll do is I'll just increase it. Okay, so now it is. Okay, it's pretty simple. Like you can do this activity. I'm going to show you. Like, see, I'm not even touching it. Okay, I'm just bringing the other magnet close to it, and it starts moving. Okay, so this is almost. See, one thing you can see is that suppose you have 1 minute in hand, you see like it goes little slow. Okay, or the force is less, and I have like 6 magnets. So much. And the other thing you can learn from this is moment of inertia, something called moment of inertia, or like moment of a transfer moment. Okay. So at what rate? The rate at which you bring your hand, that is the rate at which the car is going to move. Suppose I bring the hand very slowly. What happens? It moves slowly. And now I'm going to bring the magnet very fast. You see that like it moves very fast. Okay, so it's basically getting the moment of my hand is getting transferred to the car, and it picks up like very fast. Here, okay. So if I bring it slow, what happens? Even this moves slow. Okay. So there are like the amazing things we can actually learn with this simple activity. But this is amazing that I love to play with this. Like I just keep moving all the day. Great. Okay. So fine, children. So any questions, please ask. I think like we have come close to the end of the session. So like this, like in every class, we keep doing like 1-2 experiments and try to learn science from it. Okay, but yeah, it's almost like playing with science. Any questions? Please ask. Siddhant, Vedant, Yesh. I did not hear from Yesh actually. So any questions, children? What is that, Siddhant? What's there in your hand?
Sir, it is my skateboard screwdriver.
Oh, is it okay? Okay, good. Yeah. So fine, children. So what we do is, as I said, like we keep doing such simple activities, which is also relevant to your school curriculum. So every day, like sorry, every Sunday at 11 o'clock, between 11 to 11:45, we do these activities. Okay. So please join these activities, and you can also invite your friends. You can send the link to your friends as well, so that even they can join. So I want to see at least in one group, I want to at least see about 25 students. Right now, we are, I think, 5, but there are some students from the last class they did not join. They were been like regular, but I'm not sure why they did not join today. So the target is that like in one, if we